What is it that makes us, need to solve puzzles or keep scrolling endlessly online down some rabbit hole or just stop totally captivated by a magic trick? Even when we know it's just a trick, there's this deep, kind of irresistible pull in us to figure out the unknown.
It really is a fundamental part of being human, isn't it? That pull towards the question mark, the mystery.
Absolutely. And that drive, that innate thing, is exactly what we're diving into today on the Deep Dive. We've looked through all your sources, a really interesting mix of articles, research notes, and we're here to unpack the key insights for you.
Right.
Our mission today, to explore the evolutionary psychology behind why we're so fascinated by mysteries, conspiracy theories, just the unknown in general. We want to understand the deep psychological stuff that pulls us towards uncertainty and how that attraction actually gave us a survival edge way back when. And crucially, how that same drive can be, exploited in today's digital world.
Yeah, it's quite a journey, isn't it? From our most basic urges to the really complex challenges of dealing with information today.
Okay, so let's get into it. We're starting with the inner drive, basically, the psychological roots of curiosity itself. You shared some great material, and one source, Curiosity Evolves as Information Unfolds, really focused on what curiosity feels like. What did it say about when we feel most curious?
Well, it explains that our curiosity tends to rise with something researchers call stimulus entropy. Now, that sounds a bit technical.
Yeah, a little.
But it basically just means your curiosity gets really sparked when there's a lot going on in your environment, a lot of variety or uncertainty, just a lot of unknowns to figure out.
Okay.
And kind of the flip side, it goes down as you get more confident you understand something.
So the more mystery, the more curious we get. Makes sense. But what's really interesting is that source also mentioned that even when we are pretty confident, that drive can still make us keep looking for information. What's that about? Is it the process itself?
Exactly. It suggests there's real value, not just in getting the answer, but in the experience of the information unfolding. Think about watching a mystery movie. Maybe you suspect who did it early on. But you keep watching anyway, not just for the big reveal, but for the journey, right? Seeing how all the pieces click together. And the sources mention this process brings up a mix of feelings, enjoyment, sure, but also tension, and sometimes frustration, depending on how confident you feel about solving it.
Yeah, that totally clicks. It's not just the destination. The journey itself is rewarding. Now, building on that, a lot of researchers see curiosity not just as a feeling, but as a really fundamental drive. Can you tell us more about that drive theory from the curious or interested source?
Absolutely. So drive theory basically says curiosity is like an internal itch, an internal deficit. It creates this kind of unpleasant arousal, a feeling of incompleteness. And that feeling motivates us to explore, to seek information, basically to scratch the itch and get back to a state of cognitive balance. It's really seen as being on par with basic drives like hunger or thirst. We're just driven to satisfy that need for information.
That makes me think of the whole Pandora effect thing. We're just knowing there's a mystery makes you want to open the box, even if you suspect it might be bad news.
Yeah, perfect example. That's that irresistible urge right there.
It's a powerful drive.
Definitely. But like a lot of human traits, it's not just one simple thing. Psychologists actually talk about different types of curiosity. Daniel Berlin, who was a pioneer in this area, he distinguished between perceptual curiosity, that's more about seeking out new sights and sounds, novel stimuli. It tends to fade with exposure.
Yep.
You see it a lot in animals and human babies. Then there's epistemic curiosity. That's more about wanting to acquire knowledge, to really understand things, dispel uncertainties. And that's seen as predominantly human, a deeper drive to truly know.
That distinction alone is interesting, perceptual versus epistemic. But then another source you shared, inquisitive but not discerning, adds another layer, right? Talked about interest curiosity versus deprivation curiosity. What's the difference there?
Right, that's a really critical distinction. Interest curiosity is, kind of the good side, you could say.
Yeah.
It's linked to things like intellectual humility, being okay with not knowing everything and being open to learning. And also discernment, which is basically being sensitive to novelty, but also being able to tell, real concepts from made-up ones. But then there's deprivation curiosity.
Okay.
And that's often called the dark side. It's associated with being more likely to make like false alarms claiming you know something when you don't. It's linked to less intellectual humility and, importantly, a greater tendency to believe and even share fake news.
Wow.
Yeah, with this type, it's less about deep understanding and more about this urgent, almost desperate need to fill a knowledge gap any way you can. And that obviously makes us much more vulnerable to being misled.
That's huge. So our wiring for curiosity, which is so beneficial overall, also has this potential downside, this dark side, that can nudge us towards misinformation if we're not, like, actively thinking about it.
Precisely. It's like a superpower that also has a built-in weakness.
And all of this, whether it's the helpful kind or the more problematic kind of curiosity, it all loops back to our brain's reward system, doesn't it? How does that connection work?
Oh, absolutely. It's deeply connected. The source, Remember the Magic, explains how curiosity actually lights up our brain's dopamine reward pathways. We're talking areas like the ventral striatum, the medial prefrontal cortex, the hippocampus.
The usual suspects for reward.
Exactly. And this activation is key because it makes the information itself feel rewarding. Your brain isn't just processing data, it's giving you these little dopamine hits, literally making the act of figuring things out feel good, like getting a treat. And because of that reward, it's not just enjoyable. Curiosity actually boosts your memory. People consistently remember stuff better when they were curious about it beforehand. And this memory boost works even without obvious rewards, like money. Your brain is just wired to prioritize and hold on to whatever sparks that curiosity.
So when we ask, why do we love mysteries? It really, really boils down to our wiring. We've got this deep, almost primal urge to seek out information, resolve uncertainty, and our brains literally reward us for doing it and even help us remember what we find out. No wonder mysteries are so compelling. Okay, so building on that intrinsic drive, let's shift a bit and explore how this became such a core part of us. Our next segment is built in for survival evolutionary advantages. We often talk about humans as problem solvers, right? And one of your sources, Humans Evolved to be Problem Solvers, frames this almost as a biological need. What happens if that need isn't met?
Yeah, that's a really interesting angle. It suggests that in our modern societies where maybe the day-to-day survival problems aren't as immediate, this deep need to solve problems can actually lead to things like anxiety or even depression. We might lack those tangible challenges.
It's like an unfulfilled.
Sort of, yeah. And to cope, the idea is that people might unconsciously create their own problems, sometimes in healthy ways, like, taking up challenging hobbies, physical exercise, solving puzzles.
Right.
Or maybe in less healthy ways, like getting caught up in, say, imagined societal problems or conflicts just to have something to engage that problem-solving drive. It really highlights how fundamental that drive is to our well-being.
It's like our brains are just constantly scanning, looking for a puzzle to work on. And our evolution definitely set us up for that. The source, A Natural History of the Human Mind, talks about the big changes in our brains, Homo sapiens, compared to our ape ancestors. Not just that our brains got bigger, right?
Not at all. They reorganized significantly, especially the neocortex, the wrinkly outer part responsible for complex thought. There was this huge disproportionate growth in what are called the higher order cortical areas.
Okay, what do those do?
They manage things like abstract reasoning, planning, language.
Yeah.
Basically, the stuff that makes us cognitively unique.
Gotcha.
And these physical changes in the brain tied directly to our boosted cognitive abilities, our language skills. And if you zoom out, think about our senses, our eyes, ears, touch. Their primary evolutionary purpose, going back millions of years, is acquiring information.
Right.
We don't just passively soak it up. We actively control our senses to get the most useful information, like how our eyes constantly dart around strategic visual fixations to figure out what's important in our surroundings.
So our eyes aren't just windows, they're active scanners. And it's not just about us gathering information individually, is it? It's also about sharing it, learning collectively. How did our cognitive evolution change our social game?
Massively. Our advanced cognition allowed for way more sophisticated social interactions. For example, great apes can follow another's gaze to figure out intentions, which is pretty smart, more than monkeys can do.
Okay.
But then humans have this thing called imitation learning. We copy actions much more faithfully, with greater precision than even great apes do. And that ability to copy accurately is huge for transmitting knowledge across generations.
So we can build on what others learned much more effectively.
Exactly. We build cumulative culture. And while studies on animal cognition show that some animals can learn abstract concepts like same versus different, humans just seem to have this superior knack for taking those abstract ideas and running with them, applying them in totally new ways, creating novel concepts.
This ability to think abstractly and learn, plus that curiosity drive we talked about, it leads to something called the novelty bonus. What's that all about, and why was it good for survival?
So the novelty bonus is basically our built-in bias towards checking out new and unfamiliar stuff, even if it doesn't offer an immediate, obvious reward like food or shelter.
Just because it's new.
Pretty much, yeah. Just the novelty itself seems to increase the expected reward in our brain's calculation. And when we encounter something novel, we see a burst of activity, what's called a reward prediction error signal, in brain areas like the ventral striatum. It's like your brain gets a little extra kick, saying, hey, this new info is even better than expected.
Yeah.
And what's really telling is that our dopamine neurons, the ones usually linked to primary rewards like food or sex, they also fire up for informational rewards.
Oh, okay.
This strongly suggests that just acquiring knowledge, just learning something new, is a fundamental motivator, hardwired into our reward system. It's crucial for balancing that exploration-exploitation dilemma, deciding whether to stick with what you know works or risk exploring something new that might be better.
So our ancestors, who were maybe a bit more curious, more willing to explore new places, new foods, new tools, they likely had a real edge.
Absolutely. That drive to explore the unknown, fueled by the novelty bonus, would have directly contributed to finding new resources and adapting to changing environments. It literally paid off to be curious.
And clearly, that trait has stuck with us. It's a core part of who we are. Okay, so we've established curiosity as this powerful, evolutionarily useful drive. But this brings us to our third and final segment, the modern trap exploiting our innate drive. Because the very strength of this drive can make us vulnerable, right? Especially now, in the digital age. How do, say, cybercriminals use this against us?
Oh, it's a huge vulnerability. A prime example is social engineering. Cybercriminals aren't just throwing random attacks out there. They're often specifically trying to manipulate our basic emotions, including curiosity, but also trust.
How do they do that?
Well, they might gather bits of personal information about you, maybe from social media or data breaches, and then craft these really specific lures. Think about those phishing emails that look almost exactly like they're from your bank or a service you use.
Oh, yeah.
They'll often have some hook, like urgent security alert or unusual login detected, designed to pique your curiosity or anxiety and make you click without thinking too hard. They're playing directly on that need to resolve uncertainty.
That's genuinely creepy because it's targeting our basic human nature.
Here.
And it's not just theoretical. Another source, exploitation of human trust, curiosity, and ignorance by malware, really hammers this home. It talks about how user ignorance, trust, and crucially, curiosity are key ways malware gets onto our devices. What did that source find about how people often react, even if there are warnings?
Yeah, it highlights that a lot of users, particularly maybe less experienced ones, tend to lower their guard, even when they see warning signs. That inherent curiosity, what's behind this link, what's this attachment, combined maybe with a bit of misplaced trust or just not fully understanding the risks, often leads them to click. It's a classic example of our evolved drives being turned against us in this totally new digital environment. And you can draw a direct line from this vulnerability to the spread of things like conspiracy theories.
Okay. How so?
Well, our fascination with the unknown, that drive to find patterns and solve puzzles, when it gets misdirected or when we lack reliable information, can make conspiracy theories seem appealing. They offer explanations, albeit often flawed ones, for complex or unsettling events. And their spread definitely contributes to the fragmentation of public opinion we see today.
And this is where it gets complicated, right? Because while believing in conspiracy theories can have negative outcomes like making people disengage from politics or hesitate about vaccinations, feeling powerless.
Right. Those are well-documented potential consequences.
There's also another viewpoint mentioned in the sources. Some argue these beliefs can sometimes be seen as a way, maybe a clumsy way, but a way to challenge authority or push for more transparency from governments. It's complex.
It is complex, and we're just presenting that range of perspectives from the source material, not taking a side ourselves, but it links back directly to what we discussed earlier about deprivation curiosity.
The dark side.
Exactly. That type of curiosity is strongly linked to believing and sharing fake news. When the primary goal is just to fill that knowledge gap urgently, and maybe intellectual humility is low, that critical thinking part, the discernment, can really take a hit. We become more likely to grab onto any explanation that feels like it fits, even if it's not verified.
And this ties into how we generally deal with uncertainty, doesn't it? The source on the relationship between uncertainty and affect pointed out that uncertainty isn't always negative. Sometimes it intensifies feelings, sometimes it dampens them, sometimes it can even feel good, like anticipation.
True, but it also highlighted a common human tendency. When faced with uncertainty, we often tend to mentally simulate negative future outcomes. Our brains kind of jump to the worst-case scenario as a default.
Why do we do that?
It might be an evolutionary hangover, better to anticipate danger, but it links directly to another cognitive bias, confirmation bias.
Ah, yes, confirmation bias. Explain that again quickly.
It's our very strong tendency to seek out, interpret, and remember information in a way that confirms what we already believe or suspect. We often fail to even look for evidence that might challenge our view.
So we look for proof we're right, basically.
Pretty much. This can happen because we use a positive test strategy.
Yeah.
We sort of assume our hypothesis is true and then look for examples that fit. Or, as Francis Bacon noted centuries ago, it's just cognitively harder for us to process negative information or evidence against our beliefs. We naturally focus on what seems to fit.
And that makes us so vulnerable to manipulation, right?
Mm-hmm.
Because if some piece of misinformation clicks with something we already kind of believe, or if it fills that knowledge gap in a way that seems plausible to us,
we're much less likely to question it. We're much more likely just to accept it. Think how easily a catchy, misleading headline spreads if it confirms people's existing biases. Our brains are sort of primed to accept it because it fits the pattern we already perceive.
Wow. It's a powerful mechanism, and in today's information overload, it can really lead us down some tricky paths if we're not careful.
Absolutely. The real challenge then becomes how to consciously engage that powerful innate drive for knowledge in a way that leads to genuine understanding rather than just letting it be exploited.
What a fascinating journey this has been. We've really gone from the very core of what makes us curious, that inner psychological drive for information that need to know.
Right, that fundamental urge.
Through its vital role in our evolutionary survival, how it literally helped us thrive as a species, and then landed right in the middle of today's complex digital world, where that same innate drive can actually become a surprising weakness, a vulnerability.
Yeah, we're hardwired to solve problems, to fill those knowledge gaps, to find value in figuring things out.
And while that's been incredibly beneficial, it also means we have to be, well, mindful. Vigilant about how our curiosity is directed and how it can be manipulated.
It's really about harnessing that drive for genuine growth and understanding, not just, blindly following its pull.
Exactly. So thinking about all this, our inherent drive to solve problems, to close those information gaps, maybe the question for you listening is, how can you consciously direct your own curiosity? How can you steer it towards productive, discerning exploration rather than falling into the traps of misinformation or exploitation? What active steps can you maybe take to leverage this incredibly powerful, innate tool for deeper understanding without getting caught by its dark side?
That's definitely something we're thinking about as we all navigate the endless stream of information out there.